Good day, class. In this lesson, we will study a next type of special products. This type we know as binomials squared. Keep in mind that special products, by definition, give us a way to quickly recognize a solution or a different form, sometimes a factored form, sometimes a multiplied form of polynomials. Remember, it's a quick method to help you quickly get to a solution. So let's look at the pattern. This is just a generic binomial. We have two terms inside of a quantity. These are being added, as you can see here, and then the entire quantity is being squared. This is a binomial squared, okay? Well, the pattern that we recognize here will always yield this pattern, where that first term gets squared, the second term also gets squared, and in between we have the first term multiplied by the second term times 2. It will always turn out this way. If you recognize that you have a binomial, the multiplication of that, the binomial squared, the multiplication of that will always turn out this way. Same thing with when we are subtracting. In this case, we have the binomial squared, but it's a minus inside of that quantity. And so the first term gets squared, the second term gets squared. The terms get multiplied by, the A and B get multiplied by each other and multiplied by 2. And then the subtraction sign is our second operation. So note the pattern because it's very important and it will make your life easier when you are advancing through these assignments and through some of our practice problems. Let's take a look at a specific example. Here's a binomial. It has been squared. We actually looked at this in a previous lesson. X plus 9. Now, this is not the difference of perfect squares, we note, because we have x plus 9. So we can't, and it's a binomial in a quantity being squared. So we know that we're dealing with a binomial square and not any sum or difference of perfect squares. So we deal with it as a binomial squared. And in fact, a binomial squared just means multiply that binomial by itself. So we have x plus 9 times x plus 9. That quantity gets multiplied by itself. Remember, do not share that 2. Do not distribute that power of 2 throughout the parentheses. You multiply the quantities by itself. Multiply the quantity by itself. And so when we do this, we can fall back on FOIL, where we multiply the first, outer, inner, last, which yields x squared plus 18x plus 81. Now, notice we started with x plus 9 quantity squared. And when we multiply, we ended up with x squared plus 18x plus 81. Notice how I promised you this x squared or x plus 9 quantity squared will yield, recognize we've got a, recognize we've got b, will yield a squared, or that first value squared. The second value gets squared also, and in the middle the two terms have been multiplied by each other, x times 9, and then it's been multiplied by 2. Notice the pattern. Recognize that you have one. A has been squared, B has been squared, and the two have been multiplied, A and B, by each other and then multiplied by 2. Let's take a next look at an example. X plus 4 quantity squared. This will yield, if we multiply it out, the first term squared at the front, the last term squared at the back, and 2 times the first term times second term in the middle. And we simplify, it becomes x squared plus 8x plus 16. But you can get there quickly from the initial problem to the solution, the product. We can get there quickly if we follow the pattern. So let's follow the pattern. We have x plus 4 squared, quantity squared. It will yield x squared plus 8x plus 16. X plus 5 quantity squared will yield x squared plus 10x plus 25x. Remember that middle term are the two terms in the binomial, x and the 5. They got multiplied by each other and it got multiplied by 2. That's how we got to 10x. X plus 6, quantity squared. Same thing. The x gets squared, the 6 gets squared at the end, and in the middle, we have x times 6 multiplied by 2. That gives us 12x. Let's look at the difference when we're dealing with the binomial square. We have x minus 7, quantity squared. Same thing. The first term gets squared, the last term gets squared. In the middle, we multiply the x and the 7 by each other, multiply it by 2, but that term is a negative. Same thing with x minus 8, quantity squared. Same thing with x minus 9, quantity squared. Recognize the pattern. We also note, even if the x, for example, term does not, or the first term has a coefficient greater than 1 in this, or different other than 1, we'll say in this case, x has a coefficient of 4. That's okay. We still need to square the first term, square the last term, and in the middle, multiply the two terms and then multiply them by 2. Same thing here. Square the first term, square the last term, multiply the two terms, and multiply them by 2 in the middle. And the same thing here with 6x minus 1, quantity squared. Square the first term, square the last term, in the middle, multiply the two terms, and multiply them by 2. Respect the fact that we have negatives here, so our middle term will be negative.